Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. Voyage to Saturn. The epic journey of the Cassini mission. In the annals of space exploration, few missions have captured the imagination and yielded as much scientific bounty as NASA's Cassini-Huygens mission. Launched on October 15, 1997, Cassini was a joint endeavor between NASA, the European Space Agency, ESA, and the Italian Space Agency, ASI. Its primary objective was to explore Saturn, its rings, and its moons, and over the course of its 20-year journey, Cassini exceeded all expectations, fundamentally transforming our understanding of the Saturnian system and the broader workings of our solar system. The genesis of the Cassini mission can be traced back to the early 1980s, when scientists and engineers began to consider the next steps in planetary exploration following the success of the Voyager missions. Voyager had provided tantalizing glimpses of Saturn and its moons, but a dedicated mission was needed to delve deeper into the mysteries of this distant world. After years of planning and international collaboration, the Cassini mission was born, named in honor of the Italian-French astronomer Giovanni Domenico Cassini, who discovered several of Saturn's moons in the 17th century. Cassini's journey to Saturn was a marvel of modern engineering and ingenuity. The spacecraft was launched atop a Titan IVB/Centaur rocket from Cape Canaveral, Florida. To gain the necessary speed to reach Saturn, Cassini employed a series of gravity assist maneuvers, slingshotting around Venus twice, then Earth, and finally Jupiter. These maneuvers, executed with precision, allowed Cassini to pick up the velocity needed to travel the vast distance to Saturn, a journey that took nearly 7 years. On July 1, 2004, Cassini entered orbit around Saturn, marking the beginning of an unprecedented exploration of the Saturnian system. The spacecraft was equipped with a suite of 12 scientific instruments designed to study the planet's atmosphere, rings, magnetosphere, and moons. One of the mission's early triumphs came with the successful deployment of the Huygens probe, which detached from Cassini and descended to the surface of Titan, Saturn's largest moon. The Huygens probe, named after the Dutch astronomer Christian Huygens, who discovered Titan in 1655, made history on January 14, 2005, by becoming the first human-made object to land on Titan. Titan, with its thick, nitrogen-rich atmosphere and hydrocarbon lakes, is one of the most Earth-like bodies in the solar system, albeit much colder. Huygens transmitted data and images during its descent and for about 90 minutes after landing, revealing a landscape shaped by liquid methane and ethane. The probe's findings suggested that Titan's surface processes might be analogous to those on early Earth, providing valuable insights into the conditions that could foster life. Cassini's exploration of Titan did not end with Huygens. The orbiter made numerous flybys of the moon, using its radar to peer through the thick, smoggy atmosphere and map Titan's surface in unprecedented detail. These flybys revealed vast dune fields, icy mountains, and large seas of liquid hydrocarbons, primarily in the moon's polar regions. One of the most intriguing discoveries was the detection of large lakes filled with liquid methane and ethane, suggesting that Titan experiences a cycle of evaporation and precipitation similar to Earth's hydrological cycle, but with methane and ethane instead of water. While Titan was a major focus, Cassini also dedicated significant attention to Saturn's other moons. One of the most astonishing discoveries was made on Enceladus, a small, icy moon with a diameter of about 500 kilometers, 310 miles. During a close flyby in 2005, Cassini detected plumes of water vapor and ice particles erupting from the moon's south polar region. Further investigations revealed that these geysers were emanating from a subsurface ocean beneath Enceladus's icy crust, heated by tidal interactions with Saturn. The discovery of this hidden ocean, with its potential for harboring microbial life, was one of the mission's most profound findings. Cassini also provided detailed observations of Saturn's other moons, such as Iapetus, with its starkly contrasting black and white hemispheres, and Mimas, whose large crater gives it a resemblance to the Death Star from Star Wars. Each moon had its own unique features and mysteries, contributing to our understanding of the diversity and complexity of the Saturnian system. Saturn itself, with its iconic rings and turbulent atmosphere, was a primary focus of Cassini's mission. The spacecraft's instruments captured stunning images and data of the planet's cloud formations, storms, and changing seasons. One of the most striking features observed was the hexagonal storm at Saturn's North Pole, a persistent, six-sided jet stream that had never been seen on any other planet. Cassini's close-up observations of this phenomenon provided valuable data on the dynamics of planetary atmospheres. The rings of Saturn, composed of countless particles of ice and rock, ranging in size from tiny grains to large boulders, were another major area of study. Cassini's instruments analyzed the composition, structure, and dynamics of the rings, revealing their complex interactions with Saturn's moons and magnetic field. The spacecraft observed waves and propeller-like features within the rings, caused by the gravitational influence of nearby moons, and studied the seasonal changes in the rings' appearance. One of the mission's final acts was the grand finale, a series of daring orbits that took Cassini between Saturn and its innermost ring. This phase, which began in April 2017, allowed the spacecraft to collect unique data on the planet's gravitational field, magnetic field, and atmosphere. These close passes provided unprecedented views and measurements, shedding new light on the internal structure and composition of Saturn and its rings. On September 15, 2017, after nearly 20 years in space and 13 years exploring Saturn, Cassini's mission came to a dramatic end. Running low on fuel, the spacecraft was deliberately directed to plunge into Saturn's atmosphere, ensuring that it would not contaminate any of the planet's moons, particularly Enceladus and Titan, which have the potential to harbor life. As Cassini descended, it continued to transmit data until the very last moment, providing a final, invaluable glimpse of Saturn before being consumed by the planet's atmosphere. The legacy of the Cassini mission is profound and far-reaching. Over its two-decade journey, Cassini fundamentally transformed our understanding of Saturn and its moons, revealing a complex and dynamic system with many parallels to our own. The mission's discoveries have had significant implications for our understanding of planetary systems and the potential for life beyond Earth. Cassini's exploration of Titan and Enceladus, in particular, has opened new avenues for astrobiology. The detection of liquid water beneath Enceladus's icy crust and the organic-rich environment of Titan suggest that these moons could be prime targets for future missions searching for signs of life. The data collected by Cassini will guide the design and planning of these missions, ensuring that they are equipped to answer some of the most profound questions about our place in the universe. As we look to the future, the legacy of Cassini will continue to shape our exploration of the solar system. Missions such as the Europa Clipper, which aims to explore Jupiter's moon Europa, and the Dragonfly mission to Titan, are direct descendants of Cassini, building on its discoveries and pushing the boundaries of what we know about our cosmic neighborhood. In conclusion, the Cassini mission was a landmark in the history of space exploration. Its journey to Saturn and the wealth of knowledge it returned have transformed our understanding of the Saturnian system and the broader workings of our solar system. From the discovery of a subsurface ocean on Enceladus to the intricate dance of Saturn's rings, Cassini has left an indelible mark on the field of planetary science. As we continue to explore the cosmos, the legacy of Cassini will serve as a beacon of inspiration, reminding us of the incredible achievements that are possible when we dare to reach for the stars.